I just made this HTTP server with assembly. Let me explain what I have did here. If you haven't watched my the TCP server with assembly video, I suggest to watch the video so you can understand what is happening here. This is basically the TCP server, but it is replying back with these HTTP headers, so they can be displayed in the web browser. So let me explain what is happening here. First of all, in the previous video when I have did the TCP server, like then I just sent the message hello world, and but now I'm sending these HTTP headers. First of all, always I'll send the 200 success response, and content type is text HTML, and content length I just count the content length like 1 2 3 the step, and then the connection is closed. That means whenever the 20 the 22 byte received to the client, the connection will be closed. That means server will close the connection, and that's it. I'm just sending this as the message. uh, Whoever didn't watch my previous video, I'm just little bit explaining what is happening in here. So first of all, I just declared some constant values. First one is finet, which is stands for IPv4, and this is the sock stream. Because this is a TCP connection, we are sending streams, and this is the protocol number, IP protocol number of TCP, which is 6, and this is the message I have explained, and this is the message length. I'm just basically counting the length of these things, and in the basis session I'm just reserving some bytes for future use, like the socket file descriptor for me. When my server will listen to any IP and any port, this will be created. I mean, I will create this socket and bind a specific IP and a port of my device, and I'll listen on this socket. So any upcoming connection on the IP and port will be listened in this socket, and this is the client socket file descriptor. Whenever client connect to me, I will store the client file descriptor in here, and this is the client socket address structure. Whenever any client connect to me, it will automatically filled, and this is also the client socket address length, structure length, and whenever any client connect to me, this also filled automatically, and this is the buffer. Whenever any browser or any client connect to me, I'll store the information the client sent to me. And now in the start, you can see first I'm creating socket. If I come here, this 41 is stands for C socket, and it accepts 3 parameters. First one is the family, which is IPv4, and this is the type, which is socket stream, and this is the protocol number and syscall. Then if it successfully create a socket, the socket will be stored in the RX register, and I'm just moving the socket in my reserved variable. If any error happen, if this program cannot create the socket, this RX will be a negative number, but I'm not validating anything here, so I'm just moving the RX into socket file descriptor of myself. And after that create socket, we are binding the socket. If I come here in the bind socket code, this 49 is stands for the bind socket, and it accepts 3 parameters. First one is the memory address of socket file descriptor of my device. So we created the socket file socket and moved the socket file descriptor in this variable, so we are providing the memory address of this, and the second parameter will accept the socket address structure, which kind of like object in JavaScript or kind of. And if I come here at the ending of the code, you can see the socket address structure I have declared here, and you can see all of this family finet and the port. It's actually it's actually stands for not 2929. We'll see. It is in the network host order, and it will only listen on 127.0.0.1, and the padding and length length is just basically counting counting itself. So these things counts dynamic. And if I come here in the bind socket, you can see I'm providing the socket address structure and the length of this. It's and then syscall and return, and it will come here again here and call the listen. In the listen, I'm just providing the socket file descriptor with the backlog of 5. Backlog is basically how many connection can be stored in my accept queue. If you don't know what is accept queue, don't worry, this is not necessary for now. And after listening, our programming is listening for connecting on the IP and on the port I provided in the socket address structure, and then we are calling accept. If I come here, you can see the 42 is for the sys accept, socket accept, and it expect 3 parameters. First one is the socket file descriptor of my device, I mean my server, and it accept, first of all, it accept the socket file descriptor of the server, and then it accept a reserved address for client socket address. It will automatically filled by the program, and the socket client socket address length, it also be automatically filled, and then syscall. And when we are in here, the program will be stuck in here. After accepting, if it successfully accept the connection, the client socket file descriptor will be stored in the RX register. So we are just moving the RX register to here, the client socket file descriptor address, and then we are calling read. Oh, means we are reading any upcoming messages from the client, and this is also a synchronous syscall. So the program will be stuck in here, and whenever client send us the data, they'll proceed to the next line and the right. And if we see if we come here in the right, you can see, first of all, it accept three parameters, and first of all, the one is stands for sys, right? And this is the file address for ours. It is the client socket file descriptor. We are writing on the client socket file descriptor. We are writing what? We are writing the message actually the HTTP contents with the HTTP headers, and this is the message length which we calculated in the data section. And then syscall, this will do what is, this will write in the socket of the client. That means it will send the response from server, and then after writing the response, just close it, and the socket will be closed. If I see the close subroutine here, you can see we're just closing the client socket file descriptor. And after that, after writing in here, we are calling the accept again. That means after writing, this will try to accept any upcoming connection. So we can repeatedly request for from our browser. So let's just save it, and compile it to a executable program. And let me just clear it. Now you can see I'm running the program with the stress debugger. The stress will be show everything whatever is happening. So first of all, it creating the socket with ifinet sock stream and the protocol number of TCP, and it's returning a positive number 3. That means there is no error happened, and this is binding with the socket which is 3 with the address structure we made, and then it's returning 0. That means there is no error, and then it's listening for an upcoming connection on the socket with the backlog of 5, and it's now stuck here. Whenever we request from our browser or any kind tool, this will proceed. So I'm using curl to send a request. You can see the response is here, the hello world. And now let's test it from the browser. If I come here and paste the address and enter, you can see the hello world is coming here. So our HTTP server is working. It does not using anything with the buffer. We are reading. This is the buffer coming from the client, and we can read the route and these things to do more efficient works and many things. But because this is a simple HTTP server, we are not doing anything of this, but we could do them whatever. This was a explanation of how HTTP server works behind the scenes. Thanks for watching.